Good afternoon. My name is Tyler Joyner, and I am going to present the research project final report for the DMAIC process on topic that we chose. Let me start by the introduction by saying, being a manufacturing manager, I initially had a couple of other processes in mind that I would like to use for the DMAIC approach in order to improve process capability and reduce variation / standard deviation in the production of the parts. However, with my son being out of school, I thought it'd be a great opportunity for him to be involved in the process. He enjoys math, and kind of give him an introduction into Six Sigma tools and statistical analysis. So although our project would be a little more difficult to display our process capability, and it would add a level of difficulty to implement and control, I could still help him understand the concepts of standard deviation, some testing methods, the fishbone diagrams, ANOVAs, normality, scatter plots, time series plots, hypothesis testing, correlation, and how Minitab software could assist in providing quick vision and results to our data we recorded. So defining our problem statement, or investigation statements that our chickens are laying less eggs due to increased heat. It's the shared hobby of me and my son and I. We have several chickens, and we just enjoy having our own eggs. So we chose this so he could be engaged. After our research, recordings of our raw data, our hypothesis is that there's a direct correlation between the rise in temperature and heat and a decrease in our egg production. So I went ahead and showed him how a simple fishbone cause and effect Ishikawa diagram would work. So it would show him as a tool so we could roll down to our root cause of what our problem was. So it's pretty elementary, but it gives him an idea of how to do it. As far as literature review, we had read some research on some patterns of egg laying throughout the years and the effect that heat can play on the production of eggs from hens. And I discovered from reading a research article in the Journal of Animal and Veterinary Advances that testing concluded that heat stress significantly decreases egg production. So what we did was we took some data. The data in table 1 was our readings early on, before we had any kind of controls implemented. Table 2 represents the data that we got whenever we added a fan, and we didn't see the results we wanted to see. So we went ahead and added a third data line that represents us adding a cool mist system to the run. This is the outside of the coop where they stay most of the time. So we were thinking, well, maybe just putting fan system inside the coop was not enough, and the heat outside affected them, and maybe they needed both. So we wanted to see how those three variables played. And then you can see from our initial data that our recordings on our scatter plot represented a strong negative linear correlation between heat and egg productivity. So we went on to also show those scatter plots representing our data in table 5 when we added the fan, and then also our data for table 6. So kind of the same kind of correlation. Because I had more data in time constraints, when you had the season of heat, things are gonna only be hot for a certain amount of time. I used 20 random sample data points from the population of our first recordings and compared that data to the recordings made for adding the fan and then later on the mist system. Table 7 shows the mean and the standard deviation. So we'll talk more about that later on, but that's just a graphical summary of our raw. These are graphical summaries of adding the fan and the mist, so you can see some of the means and the standard deviation changes from the results. It says here that it was a bit discouraging that our mean actually dropped further whenever we added the fan. So we were thinking maybe there's other factors. That's why we came and we added the misting system. So we upped our average of our eggs to 8.4 from a mean of 6.4 originally. So that was doubling, and it was getting hotter outside. So we knew that what we were doing was working. Our hypothesis, the null hypothesis, is that there's no statistical significance between the three variables, and the alternative hypothesis will conflict with the null by showing that differences among the mean are statistically significant. We went ahead and ran a one-way ANOVA to test our hypothesis to conclude that there was enough differences among the means at a 0.05 level of significance, represented in table 10 and table 11. So we can see that that it concludes that the means were significant. We can see which, using the ANOVA, we can see the different samples and what they differ most from. And then we can kind of look over at our diagnostic report and see that how our egg production was distributed. So we see a little more consistency as we put in the misting system. And then this was just to show my son kind of how you can plot on a time series. It was pretty applicable to what we were doing. So I wanted to show him how an increase over time was playing a role on, I think the more the heat was controlled, that the better things got. So you can see that represented in our time series plot for when we added the mister, as it significantly started making some changes. So the results lead to a rejection of the null hypothesis. We started to get discouraged, like we talked about earlier, that our coop did not increase our egg productivity. We had limited time for testing this, and therefore it opened up much more opportunity for us to implement more potential improvements and apply tests to see real results. So we got plans for next summer to do some different things, reconfigure our laying beds, change up our feeding cycles, and see if there's any correlation, if there's any improvements by making those changes. We clearly demonstrated that our efforts brought small improvements, and now have a better perspective on the action needed to improve the problem even more. Next year, we're going to install a larger cooling system that's going to cover the entirety of the run. We'll take multiple temperature readings, including inside and outside the coop, so we can gather better data and see if there's a correlation between the two of those. And we just had a great time doing this, and I hope that my son was able to retain and get a step up on Six Sigma and DMAIC. So it was actually a lot of fun. We enjoyed it. There are the references, and that concludes my presentation. It's been a enjoyable summer, even though it's been stressful with everything. Lots of schoolwork and regular work, but I appreciate it, and look forward to hearing from you soon. Thank you.